Good afternoon, you wonderful pre-algebra students. This is Mr. Lamb, and here's a treat for you. I don't do too many screencastifies. Miss Berger has done most of them. But here towards the end of the year, I thought I'd help her out. You know, getting access to the school got harder, so we had a harder time making the videos. So I decided, what the heck, since she made all these screencastifies all year long, I'd help her out. Well, today's screencastify is probably one of my favorites. Okay, so here's the question that I have for you. How does changing a single attribute change the volume and surface area of a rectangular prism? There's a question everybody's wanted to know since the beginning of mankind. Nah, not really. This is kind of one of those specialty math questions. So first off, let's break down my question a little bit. Now, how does changing a single attribute? That's a really fancy word for the size of one of the measurements. Okay, so really all this is asking is if I change one of these numbers, 4, 10, or 3, how does it affect volume and surface area? Well, first let's start out by taking a look at the formulas for volume and surface area. So we have volume, right, equals length times width times height, right? LWH, length times width times height. Okay, so now when we look at this, there's always some debate over which one's length, which one's width, and which one's height. But to me, this looks pretty easy because it looks like volume is going to equal length, which is 10 inches, right? Times the width, which is 3 inches. Just look at the way they're laid out there. You can pretty much tell what they're guessing at. And the height, which is 4 inches, right? So we're going to take a look first just at the volume. So we have 3 times 4 times 10, 10 times 3, 30. Of course, we always want you to use your formula sheet. And we always want you to use your calculator. So 10 times 3, 30 times 4, 120. So volume equals 120. And this is volume. And I just multiplied inches times inches times inches. So that would be inches cubed, right? That's a cube. And so inches cubed is what you end up with whenever you talk about volume. So now we're going to take a look at this other rectangular prism, right? And we're going to use the same numbers. We're going to say that, okay, we're going to use 4 inches for the height, right? We're going to use now, instead of 10 inches for the width, we're going to use 5 inches. And then for the width, we're going to stick with 3 inches. So what did I do? I changed one attribute, right? I changed the 10 to a 5. So we're going to see how by changing one attribute, what happens to the volume. So volume equals length times width times height. Volume equals length is now 5 inches times 4 inches times the width. Oh, excuse me, I kind of messed that up a little bit. Let me back up just a little bit there. Here, let me erase that so that I don't get messed up too much. I guess I got out of sequence there. Times 3 inches. I don't want you to think something happened because I did the wrong thing. Times 4 inches. Okay, so what's happened? All we did was we took the rectangular prism and we changed one reading for it. So now what do we get? Well, 5 times 3 is 15. 15 times 4 is 60. So we end up with 60 inches squared. And wait, oh, now take a look at that. Volume did exactly what I did to that single attribute. I cut the attribute in half. What happened? I ended up with half the volume. Okay, so now let's go the other way. What if, instead of using 4, 5, and 3, let's change this one right here, and we're going to go for 20 and 3. So now I'm doubling it. So over here, we'll do the thing here. We'll go volume equals length times width times height. Volume equals, well, let's see. Now we have 20 inches times 3 inches times 4 inches. Now 20 times 3, 60. And 60 times 4, 240. And you can check all of my math using your calculators if you would like. Okay, so, oh, look what happened. If I cut it in half, my volume got cut in half. If I doubled it, what happened? I doubled my volume. So it's a proportional relationship, right? Whatever I did to the single attribute, that's what happens to the volume of a rectangular prism if you change a single attribute. Volume follows the change. Cut the thing in half, your volume gets cut in half. Double the single attribute, you double the volume. Okay? So there you go. We've now answered what happens to volume if we change a single attribute. Now, let's take a look. I'm going to get rid of all of this. Let's take a look at what happens to surface area. So we know surface area is 2 times length times width plus 2 times length times height plus 2 times width times height, right? So basically it's 2 sides plus 2, it's 2 times 2 sides plus 2 times 2 sides plus 2 times 2 sides, right? Actually, it's 2 times the side times 2 times the side times, because there's 6 sides of this thing. Surface area, there's 6 sides. Just ignore me. It took me a minute to come up with that, right? I'm not going to start over. So let's just look at the original size. So that would mean that surface area is equal to 2 times 10 times 3 plus 2 times 10 times 4 plus 2 times 3 times 4. So what do we end up with? We end up with 20 times, so 2 times 10 is 20, so that's 60, plus 2 times 10 is 20, times 4 is 80, plus 2 times 3 is 6, times 4 is 24, or 3 times 4 is 12, times 2 is 6. Any way you want to look at it, because you can multiply them in any order you want. Now add these up, 60 plus 80 plus 24. Well, that's 140 plus 24, so 144 inches squared is the surface area. Okay, so now remember that. So I'm going to write it over here because this takes a lot of room. I'm going to write over here the original 144 inches squared. Now remember what happened with volume. Whatever I did to the attribute, the same thing happened when I changed, for volume, the same thing happened to the volume when I changed it. So let's go ahead. We're going to change this now to 5 inches. We're going to cut it in half. 3 inches, it's going to stay the same. In 4 inches, it's going to stay the same. So the only thing I'm changing this time is the size of that length. I cut it in half. So if this does the same thing volume did, we should end up with 72 inches squared. So let's find out. So we know surface area equals 2 times length times width plus 2 times length times height. Ooh, that height got a little carried away. Let me fix that because that looks terrible. Okay, times height plus 2 times width times height. Or surface area equals 2 times 5 now, right? Times 3. Gosh, I'm going to get this right. Plus 2 times 5 times 4 plus 2 times 3 times 4. So 2 times 5, 10, times 3, 30, plus 2 times 5, 10, times 5. Excuse me, 2 times 5, 10, times 4 is 40, plus 2 times 3, 6, times 4, 24. So when I add these together, I get 70 plus 24, or wait a minute, I get 94 inches squared. But that's not half of 144. Oh, so there's the answer to our question. How does changing a single attribute change the volume and surface area, of a rectangular prism? So volume is proportional. It changes exactly how you change that attribute. Double it, the volume doubles. Cut it in half, you cut the volume in half. But surface area has no correlation. There is no proportional difference, right? It's just going to be smaller because obviously the length is smaller, but there is no, if you do this, then this exactly happens. So that's what I want you to remember. Volume does what the change does. Surface area doesn't. Okay? So there you go. We've answered our big important question. I hope that made sense to you. I know this is a little on the long side, but these are pretty big formulas. Okay, well, you guys have a great day, and I will talk to you guys later.